Real race car engines don't have dots. That bottom gear ain't ever shearing off. I'll guarantee you. If this thing was to ever shear off all these extremely hardened, superior material lugs, there is a big freaking problem. You are not adjusting your valve lash. If you are, stop. Wrong. That is not the way you do this. There is nothing in an engine that pushes the crankshaft forward or backward except the transmission or something you bolt onto the front. That is the difference in between engine builder and engine assembler.
Yo, Steve. Making a lot of noise back here. What are you doing?
Less than what Kyle's making over there moving trash cans. So, yes, just gap and rings. Let me check this gap before I forget. I'll show you a couple things here. Now, first, the scratch and dent big block. This isn't a big block Chevy. Not even close. SMX. Now, this is, I told you earlier, this is 5 years old. This is one of the original blocks. So other people have original blocks. Bailey has the original block. Obviously, Clarkey has the original block. If you remember, this was the Mass Exodus engine. This is the engine we were going through. Everything was great, making perfect passes, and decided I would try a different connecting rod that I never had tried before, and I'm never trying again, okay? And instantaneously, on a record pass, all 8 rods blew apart. I know, harmonics, frequencies, whatever. I had the material tested. The material was not right. It was not the same material as the current rods that we use now. Don't want to get in a pee-in match. Don't care. It's a long time ago. Doesn't matter. Just giving you some history. So that did a lot of damage in here into the block. So I had to repair. I think there was a bad spot here, bad spot here. You can see some random stuff that just is cosmetic, okay? This is like having your point blank. I know you guys, some people really think that this, oh my gosh, that matters, like it's gonna be destroyed. No, it's not. These kind of cosmetic things right through here is like telling me that your Lamborghini that somebody just ran a grocery cart into is no freaking good anymore. You gotta sell it and get rid of it because it's junk. That's not the way this stuff works, okay? There's nothing wrong with it. It's just cosmetic, some little stuff that's in there. Now, this has also been running. What caused the main cap breakage? That one, boy, I don't know, because the other ones, you know, it's something. The thrust bearing, I'm 99.9% sure what causes that. I already knew that. I was kind of giving you guys the opportunity to look at it and run your ideas by it. Think about it. Get you thinking. That's what's up with this block. So if you look on other areas, and there's only scratch and dent down here. There is no scratch and dent anywhere else. This thing is just really sweet. Everything up here is no scratch, no dent. This thing is just really good. Now we got the lifter bushings in. Everything's all sweet there now. I got the new main caps for it with revisions to make it better. No sharp radiuses like was made there previously. I did not make this first block. The first batches of blocks I did not make. I've always been the one. This is my design. I had it built for me by Dart by Dart, who used to build billet blocks. They don't really do that anymore. They made the main caps. They made the block per my design and per my instructions. So that's where we're at with that. So something I thought I would show you tech-wise, that is a free gap number. Or I can measure that and tell you what the free gap is on that piston ring when it was brand new. When this thing gets used and it sees heat, what happens is it's compressed. It's right down here. When it's in the cylinder bore, it's like that, okay? So it has some tension on it. What happens when you heat something up that's got some tension on it? It tends to stay there, okay? So when you take this ring back out, we can measure that free gap number I don't bother measuring it because we don't keep the rings around that long enough to know or care. But I can tell that when the free gap is supposed to look like that, and I take a ring out and it looks like that, I know that that's wrong. Okay. Now remember, this is how tight it is. You know, they're about 32 thousandths gap when it's in the cylinder bore. Okay. That's the gap that we grind into it. I'm gapping rings right now. Now this is the second ring. Top ring is the exact same way. If you take a top ring out and it's collapsed, has no free gap left there anymore, that means it's taken so much heat that it's actually taken tension out of the ring, and it is no longer, it has a lot less, doesn't have zero, has a lot less cylinder pressure up against the cylinder, okay, making it seal. But it would have a lot less. Now when you get into the second ring, here's the tricky part. When heat has made it all the way past the top ring is fine, but the second ring now is collapsed. What would you do? Let me tell you. What you do is you call up Total Seal and say, hey, that second ring that I've been running in the engine is no bueno. That thing needs that. We need to have a different option. And they go, okay. But I still need it in a Napier, which means it's a hook groove, scraper oil ring, second ring. And so they make custom rings. So god darn expensive. I mean, you're looking at a $600 set of rings. That takes the heat, takes the temperature, stays sealed up, stays scraping oil. Because once this ring stops scraping oil, it's a smoker. Okay, that thing is pumping oil like a banshee.
So what's the difference between this kind of piston and like a Pro Mod Hemi?
Okay. Outside of this not being a Hemi, being a wedge, but yeah, lots of confusion. I say this in almost every video. In fact, I do say this in every single video that I talk about in the SMX. This is made to drag and drive. This is not made for maximum horsepower. You know what kind of engines are made for maximum horsepower? Hemis, Pro Mod Hemis. Okay? Could we build this for absolute maximum horsepower? Sure we can. Would it compete with a Hemi? No, probably not. There's certain nature of Hemi that lends itself to a couple things. It's a long story. Okay? One of them is that they will tend to RPM, make horsepower at peak RPM higher than a wedge style engine. The one main thing that you're going to notice here is compression ratio. Why compression ratio? Because we drive these on the street with 87, 91, 93 octane gasoline. Take your Pro Mod Hemi, any Hemi, Proline Hemi, Noonan Hemi, it doesn't matter who's Hemi in Pro Modified. Why don't you go run that down the street for more than 30 seconds on 93 octane fuel? There's no water in the engine. These are water jacketed driving engines. We pull trailers with these engines. Okay, so that's the main difference. They're the different engine platform. Low compression. We have to run this thing on pump gas and run it on methanol and then run it back on pump gas again and pull a trailer and drive 1,000 miles plus all in one event. So it's a different combination, different deal. I know people wanted to see the SMX in Cletus's Eagle. 100% understand. My niche is not the Pro Mod Hemi market. That is not my deal. Can do it, might do it someday. You never know. Somebody really wants me to, but it's not my niche. So I totally understand. He goes over Proline, gets a maximum effort, not a drag and drive. Eagle cannot drive out of the drag strip. It ain't. It doesn't have any water in it. How are you gonna put pump gas in it and drive it down to the gas station or drive it more than a mile? You're just not. So they're two totally different engine platforms, and that one primary thing right there is actually a dish piston. And so because we need to maintain compression ratio to run these on the street, run them at 200 plus degrees, boil the water out of them, do whatever everybody does on these things, and they gotta live. So anyways, I thought you'd find that interesting. Pistons, the design, what the engine, SMX engine is compared to the Proline Hemi, compared to anybody's Hemi, Pro Mod Hemi in the Pro Mod world, okay? To any one of those cars, totally different. Maximum effort, Pro Mod engine versus drag and drive needs to sit and idle for 8 hours straight, whatever it is. I mean, it's just stupid what we have to do with these cars. So there's a lot of compromise. Can't put the same amount of camshaft, can't put the same compression ratio, can't do a lot of the same things you can do in a maximum effort engine that's only designed to run for 5 or 6 seconds at wide open throttle. Okay, and never meant to just sit there and idle for hours on hours stuck in traffic. So let's get back to putting the rest of this together. So I'm gonna finish gapping these rings, and then we'll go over there and start putting this together. Okay, so this is your common crankshaft snout, right? Dual keyways, normal deal. All right, no big deal. Your bottom gear, you know, goes on, slides on, blah 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 blah, such and such, right? Okay, so that is just a standard Chevrolet deal. Now the one thing it does have is this is my rollerized thrust bearing set up here. So this gear would go on there, and then the bearing would be in there. Okay. Now, come over here and look at this. Now that is a turbo crank, and what I've done is I'm not doing turbo cranks anymore. I'm doing them all as a supercharger crank. What's the difference? The only difference is from here forward. All right. So, ready for it. All right. So, how this works is a little bit different. All right. So this is my thrust plate bearing, or backer bearing. I'm not sure how you'd say that, but this goes in here like this. Okay. Now the crankshafts are made specifically for that bearing. All right. Now, if you look in there, you see the nice little holes that are all lined up, little slots right there, because the bottom gear is there. No keyways. There is no keyways to index this. So guess what? There is no dots to line up. Real race car engines don't have dots. How about that? All right. At least big race car engines don't have dots. So we'll just put it has just a very light slight press on it. And since it doesn't matter what orientation it goes into, I just need to get it to fit into the crank. And these lugs right here drive that bottom gear. So guess what? That bottom gear ain't ever shearing off. I'll guarantee you. If this thing was to ever shear off all these extremely hardened, superior material lugs, there is a big freaking problem. Okay? A big freaking problem. So this all locks together like that into the crankshaft right there. And this is a El Permanento deal. All right. So I'm going to be putting that on. Then what you're seeing here of what the real spline drive part of this is this. So these spline drive hubs now no longer take a regular balancer. They are going to take a spline drive hub. All right. And this part is for the blower, because turbos, the only thing we're driving off the front of the crankshaft is an alternator. It probably takes 10 horsepower to drive it, whatever. What we're driving off the front of a blower deal is 5, 6, 7, 800 horsepower of drive force on the front of the crankshaft. Not kidding you. That's what it is. Okay. That's why they break belts. That's why they break gear drives. That's why they break blowers. That's why they shear keys off. So they make this into a spline drive. This is an RCD spline drive. Let me show you the hub. All right, so now this is the RCD. This is the female spline of the drive hubs. All right, and that will also know into orientation wherever the spline lines up at. And they are tight, very, very good splines. All right, so that whole package will drive in together like that. And this is also bottomed out, because in order to make this all work, here's a spline. So how does the bolt not push it all the way past the splines? Through this little ledge right here that rides right there. Okay, so it will go exactly about right there. And it'll hit against this shoulder, not allowing the hub to drive in any farther. Then you say, how do you put a balancer on that? Let me tell you. Now some guys in the like a screw blower car or something like this, this is the same setup as a Pro Mod Hemi. Everybody loves to say Proline Hemi. Same thing, exactly the same. They might have a slight different spacing on it, whatever, but this is the exact same deal. You put a trigger ring on here, and you could put a normal balancer on it. But what I have, Innovator West makes a RCD lower hub balancer. Now there's a little sticky spot there, but that will go on and bolt through, and that gives me my 12-1 magnet wheel, or knock them out for a Holly system and have 4 magnets on it. So then this would, your blower pulley, if it is a Pro Charger, it'll have that a 12-puck hub adapter that bolts to these 6 bolts, big hardened bolts through there. If it's a regular like screw blower or something like that, or big roots blower that just has a pulley that bolts to this, bing, 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 bing. Very cool. All right. Then when it has a regular blower pulley on it, this sticks out, and then they grab this with a front bearing support for like screw blower or something like that. So it has like a bearing plate that will go on the front of that. They'll make this a little bit longer. I don't need it longer. In a turbo application, I don't need that. In a Pro Charger application, you don't need that. Only in a big like whip screw blower or big roots blower would you need something like that. So that is how this all goes together. Alrighty, so to show you how to do the rollerized thrust bearing, there's some confusion on this engine right here on the scratch and dent. When I was sanding on the thrust surface, people thought that's wrong. No, it's not wrong. It's freaking right. And the reason why, don't get your brains bunched up, I'm not trying to prove all the haters or all the people that don't that they're just haters wrong. That's not the point. I want to show people and get people to understand how things really work. So that's why I'm explaining this. That's why I'm going over stuff. When I read comments, I see things and go, haters really don't care about it. You guys don't bother me. You can leave your comments if you want. Make sure they're good ones though. And then, but with everybody else, I am just trying to show people how things really work. Use your brain, think about it logically, how something works, okay? So we're pushing the crankshaft all the way back. It's a 0, okay? Now we push the crankshaft all the way forward. This has 10 thousandths of thrust on a stock bearing, brand new crankshaft. This is our brand new crank, stock bearing, all right? Now, what we're going to be doing here is then I want to make sure that as I put my roller bearing assembly all together, so this is a Torrington bearing, all right? You can see here, 2 shells, the Torrington in the middle, goes like this. This plate here, how it all goes together, just like so. So that presses up against here and keeps crankshaft from going any farther forward. So what I have to do is I have to make sure that it actually is hitting this, that it's not hitting the thrust bearing in the back side. So when I push this crank all the way forward, which is 10 right there, what I actually want this to do is I want it to be less than 10. I want it to be like, this needs to move it, oh, let's just say, like there. If I don't touch that thrust bearing, I bolt this all on, and it changes to 5 thousandths of thrust, that means it has to go 5 thousandths of thrust forward before it would ever hit the back of the bearing. Now, this can move, especially if there's too much charge pressure, too much converter lockup pressure, whatever it could be right there. Pushes too hard on this, it could still I'll push this forward a few thousandths more and really hit that rear thrust bearing super hard. FYI, every GM bearing in the world is only designed for about 90 pounds of converter charge pressure. So 90 PSI pushing forward is the maximum that these bearings were ever designed for. And that's a maximum short duration. Okay, so if they're sitting on there on chip for a really long time, there could be a big problem. Sitting there trying to spool up, hence the turbo car problem, hence the rollarized thrust. Okay, so I'm going to be setting this all up so I can get that. Now, if this pushes it a little too far back and there's 0, then I got to sand this front side of it. What I The main thing that we want is we want it to always be pushing against the rollarized bearing, not the stock thrust bearing. There is nothing in an engine that pushes the crankshaft forward or backward except the transmission or something you bolt onto the front. Spinning around doesn't freaking matter. None of that stuff matters. It does not make the crankshaft go forward or backwards. Period. So what I'm going to do is I'm going to set this up. I'm going to show you how it is. We might have to trim up the back of the bearing, maybe. We might have to trim up the front of the bearing, but it's all only. So we're just doing micro adjustments just by a few thousandths in order to make it properly ride on this Torrington bearing. The bearing assembly all on there. I'm going to show you how this all works. I also put the rear main cap on there, did all that stuff. Now, let's take this thing, let's make this loose, and I'll show you how this is working. Now, I did have to modify this. Now, this time, because these are $5,000 freaking crankshafts, right? But as far as minor stack up points and like, you know, this thing is a couple thousandths different in or out. It is totally acceptable within range of, you know, within the range of acceptability. It's no problem. That we're not talking about sizes of the journal. We're not talking about stroke or anything like that. But like, for example, if this counterweight diameter is 5 thousandths larger than this one, or more importantly, if it's 5 thousandths larger than the other crankshaft that's in the brand new crankshaft that's in a box, who cares? Okay, it's not a critical dimension. This one little spot here is not a totally critical dimension because everyone needs to be adjusted. I can't get, like I said, this is the dart block, so this is 5-year-old block. It's been, you know, scratch and dent model. Every block, I mean, there's little stack up. There's just always all these little critical dimensions. Sometimes every little thing you're just going to have to touch. Okay, that is the difference in between engine builder and engine assembler. You know, if you just want to be assembling something, just put it all together and it just works. That's cool. I wish everything was like that, but there wouldn't be any need for a guy like me, who's trying to teach guys like you how things really work and how to do things. As things get in these bigger ranges and bigger things, the critical clearances are critical, and I have to sometimes touch it, massage it a little bit to make it exactly right, versus just bolting it on because it fits within parameters. Okay, so now let's just look at this real quick. This is loose. Okay, it is not making contact. So this is on the thrust, the stock factory thrust. You want to get right there, Nate? That's 0. Okay. Now I move the crankshaft forward. And we are. Well, that's a little bit interesting. It's just a little bit less, but that's because I put the cap on, and that upper bearing is probably just that much different, about 3 thousandths different. Doesn't matter, because what we care about is where this thing is pushing backwards to. Okay, so that is 0. All right, you see this? Pushing the crankshaft backwards. All right, now I'm going to push the crankshaft forward. Okay, and we're at 6 to 7, right around there. And I'm going to tighten up my bearing on the front, which is should touch the crankshaft. Should touch the crankshaft and actually just push it back a little bit so it's not riding on the back thrust. Okay, so I've moved this crankshaft all the way forward, so we'll be able to see as I tighten this up, it go back. Watch the gauge. I'm tightening this up. There we go. All right. So now the bearing assembly is tight. It's on there. All right. We come back and we go back to 0. Yeah, it's still 0. And now it is only 4 thousandths. Okay. So we know that crankshaft is pushing on the forward thrust bearing. It is hitting the thrust bearing because it is not allowing it to go all the way forward, which was 8 thousandths, 7 to 8 thousandths. Not doing it. Now, this is something that you can kind of see too. Watch the gauge here. Watch my screwdriver. I'm going to pry on this thing, and this is what's probably going on even though this bearing assembly is really good, too much pressure can move and squish and push that bearing plate back a little bit and take up more clearance and then hit the back of the thrust bearing, the stock bearing, which is what's happening in this originally. Too much charge pressure, too much something going on, lockup pressure, trying to figure it all out. I know what's doing something. Something's pushing it forward. Okay, period. So there's no doubt about that. But this is the way what we were setting up, and this particular time, so that's crankshaft all the way back. That's up against the front of the bearing. Now this is all the way forward. We can see that where it starts hitting is right there about 4. We now know that it is primarily using that Torrington bearing in the front. So how I adjusted this is I didn't have to do anything with the bearing in the back because the back was set nice. Had to make some adjustments in this cage, in the bearing cage, this cover right here. So on the inside of this, I actually had to put it up in the lathe and I cut the inside that you can't see right here. Cut the inside where the bearing goes to give it a little more clearance because it was pushing too far backwards. It was too tight. So I loosened that up. So all stuff you have to do. Now, this whole bearing assembly and rear main will stay with this crank and this block all the time. But anytime you change the crank or you change a block or you change the gear drive stuff, you're going to have to reset things up. Okay? So that is something cool right there. So I'm going to start working on assembling the rest of this thing, get things all tightened up, and get this crankshaft the rest of the way in. All right, so 2 things. First, I did the camshaft, had to take it back out and put a shim on it. And yes, there was lube all in the bearings. I didn't bother lubing up the camshaft. I just put it in on the journal. But here is something that you find interesting too. So your normal balancer bolt, this is the one that came out of it, which is a big, really actually a big bolt. That's the one that comes out of it, and it's just like your typical bolt, okay? Goes in the end of the crank, tightens everything down. I think that's the normal good way of doing it. There is a better way. Here is the better way. You use that bolt. And then what this does is it goes all the way through this entire snout where the spline drive is on, the gear drive gear is on, the whole snout area right there. And this actually threads into the counterweight. So it is pulling the whole thing together, all of it. The whole snout of the crank is pulled into the counterweight, or the end of the crank is pulled into the counterweight, which is like the front of the crank, the very meatiest, strongest part of the crank. Instead of everything being bolted and held on to the very end of the crank right here. So now you have this great big long bolt that goes all the way through, sandwiches everything in, pulls it all together right there. Something you might find is interesting too is that you want to know how pro modified guys, especially pro modified guys and top fuel guys, because this is the top fuel bearing, connection rod bearing, which is the same as the Pro Modified Hemi bearing, which is the same as this bearing, okay? They actually buy these are called a sleeve of bearings because they change bearings so often in between rounds sometimes, check bearings, look at bearings, definitely in top fuel, but in Pro Modified, like pretty common. You know how many times we change bearings in a drag and drive event on an SMX? Never. Because it can't. Nobody wants to do that in the middle of a drag and drive, change bearings. Is it possible that you might have to at some point in time? It's always possible, especially if you miss your tune-up or something wrong. But in general, that is one of the differences on when you're leaning on these things like they are in a Pro Modified Hemi, and you are leaning on them hard. You're replacing bearings, replacing rods. You know how many thousands of miles we put on connecting rods on an SMX engine? And passes, hundreds of passes, thousands of miles is what's expected to make 4,500 horsepower in the SMX. But that extra horsepower level going from the SMX to that Pro Mod Hemi, replacing rods every 12 passes, I think is what Proline told Cletus. I think that's what it said, which means you're going to change bearings, and probably you're going to change bearings or look at bearings in between rounds at some point in time. But it's funny. This is the way they're bought in bulk. It's like going to Costco or Sam's Club and buying bulk bearings because you go through so many of them. I get them this way because it's actually just a cheaper way of doing it. And that's it. All right, new lifters here. Now these lifters, so this is the first prototype set of these lifters. And what I had them do, so I call up and talk directly to John Callies, and I think it's John Morrell. I'm not sure what Morrell's first name is. I think it's John. And showed him a video, showed him exactly what all was going on. And he goes, hold the phone. We're going to fix that. We're going to make this thing better. Cool. That's what I like to hear. So if you recall, I talked about this previous video on this engine. We did the teardown on this engine right when I got it back from Cletus. And we actually got it right back from Kevin at KSR. He's had it for quite a while. But that one of the problems, and I don't know why it's only happening. The worst case is it's happening in Cletus. So I don't know what's going on there, if it's oil problem, if it's some kind of other problem. But it would break the pin. It'd break that pin right there, allowing this axle to turn. When the axle turns, it would gouge up the bottom of the cylinder bores. Some of you guys had fine ideas about, custom making that. So in case it did turn the pin, that it wouldn't gouge up the cylinder bore. Yeah, that's all cool, but we need to get it so it doesn't break the pin. So, talking with John, and he goes, I'm going to fix this thing. So they did a custom, or they're doing new pins for these things, because that's how they take these things apart, too, to rebuild them. You have to have that pin in there. So this pin is some kind of unobtainium, made out of unobtainium, top secret squirrel material. He actually told me, but I can't remember. But I know that it is hardened to 356 kPi. He told me that. I remember that number.
It's written on the box.
Because I wrote it on the box. So I would remember it. And whatever that means, but this is some, top secret squirrel super strong pin that we believe is going to eliminate that. Because there's not a ton of force on there. I think it's just when it sits, and I do kind of think it's got to be maybe some kind of oil issue. Not super sure yet, because this is different when it's a bushing like this. These things are awesome. But if it was a bearing lifter, the bearing never locks up unless it blows up the bearing. Then it sends needles all over the place, right? So this, whenever we do have some kind of problem, it never does that. But the needle bearing in there would never lock up like this had done previously, only with really only with Cletus and a little bit with Ned Dumphy and his Viper. So anyways, we have this, and I'm really excited, and they're going to be changing all the lifters to this. So all the updates will be with this new hardened pin, hardened unobtainium Billy Bad Boy pin. So anyways, I'm going to start putting this thing the rest of the way together to get the heck out of here. All right, so a quick valve lash video for you. Explain a couple things here. Always adjust the exhaust valve as the intake valve is almost closed, as in going closed, okay? Then you adjust the intake valve as the exhaust valve is just starting to open. So adjust the exhaust valve as the intake is closing. Adjust the intake valve as the exhaust valve is opening. That makes sure that you get it on the back side of the journal. Now, a couple things I see people do wrong all the time is on a shaft mounted rocker arm, you roll this thing over until the rocker arm is loose. Then you take the shaft off. Do not back that adjuster off. Don't do it. Because when your rocker arms are marked, there's no problem. You just put it right back on. Beep, beep. You don't even have to relash it. You don't even have to check it. Okay? And when you take that off, you have a tendency to just screw stuff up. And we're always trying to figure out, and remember, so do that. Always get it loose before you take the rocker arm off. Don't back the adjuster off because it's tight. It's just roll it over until it's not tight anymore. And then the key to what valve lashing is doing is you are not adjusting your valve lash. If you are, stop. Wrong. That is not the way you do this, okay? What you're doing with valve lash, if you feel like it and you want to adjust it 1/2000, whatever, it changes it changes as the temperature goes up outside. It changes whatever temperature the engine is. It just, every time you roll it over, it's going to be just slightly different. If you feel like dinking around with it and doing that, that's cool. Come into it and you go to check your valve lash, or keyword on check, and this thing is like got a 1/4 inch. Do not adjust it. There's something broke. That's what I say. If it's more than a couple thousandths or 4 or 5 thousandths, you have to really keep track of it. Don't adjust it. Find out what's wearing away, what's breaking. Valve lashing is not, valve lash, you're checking valve lash is exactly that. You're just checking it to see what changed. If there's a change, you need to figure out why. Is it because the temperature is different and it changed a couple thousandths? Is it because there's now a 1/4 inch of valve lash? There's something broke. But either way, you are just checking to see if what's moving, seeing if something has broken, not adjusting every round in between passes. That is not the way to do it. You every engine, doesn't matter what engine it is, you're just checking to see, make sure that everything is the same. All right, so get back at this. We're going to button this thing up, get an intake manifold on it. We're going to talk about this deal quick. Alrighty, now if your valve train is set up good, here's one thing that you can do a super quick check on. I look at people's stuff all the time. Somebody will take the valve covers off, and I'll go, thing isn't set up right. What you want to have is all of these, let's see, all the adjuster nuts need to have the same position. Now, sometimes the exhaust will be slightly different than the intake. That's fine. But all the exhaust should be the same. Got a little cut in my finger. See how high that is? How high that is? How high that is? How high that is? Come over this side. Basically the same, basically the same. That's slightly different. Basically the same, basically the same. Intakes. Bing, 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 bing. Intakes over here. Bing, 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 bing. Notice. Now, if you have something, you got one adjuster nut that's all the way like that, and the rest of them are like this, there's a problem. Stop. There's a problem. You have to figure it out. Or vice versa. If the nut or the bolt was sticking all the way up, there's a problem. So anyways, little stuff that you need to look for and how you're lashing valves, what you're actually looking for. You're just checking. You're not adjusting. If you have to adjust, and figure out why. Why are you adjusting the valves? Could be perfectly good reason. Just a little bit of wear. It's just breaking in. But pretty much after the engine is broken in, making passes, all happy. I don't lash the valves on my wagon right there. Everybody's car, all we do is check, don't lash after you're driving. So it takes initial set and it should stay basically right there. So anyways, that's it. Now, Kevin has the actual manifold down there because he was still building some cold side piping off the Y or off the T back there for the dual throttle bodies. But let's put that on, and now I'll show you the new revised. Alrighty, so here you go. Camaro engine for my sugar mama / for Kyle. Kyle's gonna drive it quite a bit. Val's gonna do drag and drive kind of stuff with it. Yes, I'm rubbing the intake manifold because it's really nice. This actually isn't the intake manifold for it because Kevin has the intake manifold. And but I thought I'd show you. See, we still have my engine out of the wagon right here. Scratch and dent. Slightly scratch and dent, but it's it's the wagon engine. It's still staying in there. I thought you might find this interesting. Remember the plates that OCD Kevin made for us? That's what we just turned it into. Ability goodness. So, anyways, what's this all going in? This is now a direct duplicate of this. This is the wagon engine. This is the Camaro engine. Don't have a name for the Camaro yet. It's not going to be black. It's going to be some other color. Probably blue. So anyways, 540 cubic inch. 540 cubic inch. 104 millimeter bullseye turbos. 104 millimeter bullseye turbos. It is the exact same engine. Same cubic inch, same everything. This just happens to be more a scratch and dent model. All right, so that's what's going in the Camaro, the clone to this engine in the Camaro. Hopefully, like 800 pounds lighter is the goal than what the wagon is up on the rack. Alrighty, so that's what's all going on. Here's just a couple little clippets on the Camaro. You want to see a whole bunch of information on that. It's going to be coming up because we're going to be sending this down to Kevin for install right now. In fact, as soon as they come to pick it up. And we're going to be testing here pretty quick, Lord willing.
Check this thing out. It's what she looks like with body off. Looks completely different outside of the car, or outside of the body. That is just cool. Oh, it's shiny. Shoo, that looks good. That was a hot job. Starts the fitment of this. Ooh, more carbon. It's not the first one. Oh!